Welcome back. In part 1, we mapped the entire exam, 4 domains, weighted by importance. Let's do a quick recap before we dive in. The single most important number from part 1, domain 1, is worth 27% of the exam. That's why we start here. Claude comes in 3 tiers: Opus for deep reasoning, Sonnet for balance, Haiku for speed. The exam tests when to use each one. The SDK wraps the API. One Anthropic client handles authentication, retries, and response parsing automatically. Questions are scenario-based. The exam tests your applied judgment, not memorized definitions. Study order matters. Domain 1 first. Everything else builds on the Agentic Loop concepts we cover today. And here's what's on today's agenda. 6 things that completely cover task 1.1. Let's go. By the end of this video, you'll be able to design, explain, and reason about agentic loops at exam depth. Here's what we cover: 6 concepts. First, the communication stack. What actually happens between your code and Claude servers across 4 layers. Second, messages.create, the one function you call in every agentic loop. 5 parameters, 2 of them required. Third, the most tested distinction in domain 1, tools or descriptions, not code. We'll unpack exactly what that means. Fourth, the 4-step loop itself, the repeating pattern that powers every Claude-driven product. Fifth, model-driven agency versus scripted automation, a distinction the exam tests consistently. And sixth, 3 anti-patterns, patterns the exam expects you to recognize and reject. Let's start with the stack. Before we write any loops, you need to understand what actually happens when your code talks to Claude. There are 4 layers. At the top is your code, Python or JavaScript. You write logic and call a single function. That's all you interact with directly. Below that is the Anthropic SDK, a library you install that wraps all the HTTP complexity into simple, readable method calls. The SDK talks to the Claude API, which handles authentication with your API key and routes the request to the right model. At the bottom, Claude servers run the language model and return a structured response object, not plain text, but a structured object you can reason about. Think of it like a restaurant. You're the customer, the SDK is the waiter, the API is the kitchen ticket system, and Claude servers are the kitchen. One line of code creates a client that handles all 4 layers automatically. You never write raw HTTP. There's one function you'll call in every agentic loop. Let me walk through its 5 parameters. First, model required. This specifies which Claude processes your request: Opus, Sonnet, or Haiku. Second, max_tokens, also required. A hard cap on how long Claude's response can be. Set it too low and responses get cut off, which creates a distinct stop reason we'll cover shortly. Third, system, optional but powerful. Persistent instructions that shape every response. Think of it as a permanent job description for Claude in this session. Fourth, tools, optional but essential for agentic behavior. This is where you declare what actions Claude is allowed to request. More on this in the next slide. Fifth, messages, the full conversation history. Every user and assistant message exchanged so far. This is what makes the loop work. The agentic power lives in tools and messages together. Tools tell Claude what it can do. Messages carry the growing record of what it's already done. This is one of the most tested distinctions in domain 1. Tools are not code, they're descriptions. When you give Claude a tool, you give it 3 things: a name, a description, and an input schema. That's all Claude ever sees. Claude never sees your actual implementation. When Claude decides to use a tool, it responds with a structured block saying, "Call this tool by name," with these inputs. Your code receives that instruction and runs the actual implementation, whether that's calling a weather API, querying a database, or reading a file. The result feeds back to Claude as a tool result message. The pattern is clean. Claude decides what to call. Your code decides how to execute it. For the exam, any question about giving Claude the ability to perform an action, the answer always involves a tool description plus a separate function that does the work. Every call to messages.create returns a structured response object. Two fields matter in every loop iteration. First is stop_reason, why Claude stopped generating. End turn means Claude is done. Tool use means Claude wants your code to act first. Max tokens means the response was cut off before Claude finished. Second is the content array, a list of blocks. A text block contains Claude's narration or final answer. A tool_use block contains a tool Claude wants to call. A single response can contain both. Each tool_use block has three fields: an ID that uniquely identifies this call, the name of the tool Claude wants to use, and the input object Claude chose. That ID is critical. When your code sends the result back, you must reference the exact same ID. Tool results always go back as user role messages, wrapped in a tool_result block. Now we put it all together. The agentic loop is 4 steps, repeated until Claude signals it's done. Step 1. Call messages.create with the complete messages array and your tool definitions. Claude receives the full conversation history, every prior message, every tool call, every result. Step 2. Check stop_reason. This is the only decision point. If it's end_turn, exit and return the answer. If it's tool_use, continue to step 3. Do not try to infer completion from Claude's text. Step 3. Execute every tool Claude requested. Scan the content array, find all tool_use blocks, run each implementation, collect the results with their IDs. Claude may request more than one tool. Execute all of them before continuing. Step 4. Append Claude's full response as an assistant message, then append all tool results as a user message, and loop back to step 1. Both additions are required. Claude needs to see what it said and what your code returned before it can decide the next step. Let's make this concrete with a real walkthrough. The task: get the weather in both Tokyo and Paris. Iteration 1. The messages array has one item, the user's question. Claude responds, request get_weather for Tokyo. Stop reason is tool_use, so we continue. Your code calls the weather implementation and gets a result. Iteration 2. The messages array now has 3 items. Claude reads all of it, sees it has Tokyo's weather, and now requests get_weather for Paris. Same pattern: execute, collect result, append. Iteration 3. Messages has 5 items. Claude reads the full history, sees it has both cities, and responds with a text block summarizing both answers. Stop reason is end_turn. Loop exits. The key insight: you never explicitly told Claude to check Paris next. Claude figured that out itself by reading the growing conversation history, knowing what it already fetched and what was still missing. That's model-driven agency in action. Let's contrast 2 ways to build a multi-step workflow. In a pre-configured approach, your code hardcodes the sequence. Step 1 is always search. Step 2 is always calendar check. Step 3 is always payment. The order is fixed regardless of what the user needs. If the task only needs 2 steps, your code still runs all 3. You, the developer, are the planner. Claude just fills in the blanks. This is automation, not agency. In the model-driven approach, Claude reads the conversation context at each iteration and decides what tool to call next based on what it knows so far. If the search returns nothing, Claude might try a different query. If the user's request only needs 1 step, Claude calls one tool and signals end_turn. Claude is the planner. Your code is only the executor. For the exam, when asked how a Claude agent should decide which API to call, the correct answer is that Claude reads the tool descriptions and conversation context and decides. Not that your code checks a condition and routes. Let's go deep on stop_reason, because it's the most important structured field in every response, and the only reliable way to control the loop. Tool_use means Claude is not done. It's identified a tool it needs to call to continue. Your response: find all tool_use blocks in the content array, execute every one of them, and loop back. End_turn means Claude is done. It has all the information it needs and has produced a final answer. Your response: break out of the loop and return the text to the user. Max_tokens means the response was cut off before Claude finished, because it hit the token limit you set. The answer or tool call may be incomplete. Handle this carefully. And the critical warning: never parse Claude's text output to decide whether to continue. Checking for words like done or finished is fragile and unreliable. Stop_reason is structured, deterministic, and always present. Use it. The exam actively tests whether you can recognize these 3 anti-patterns and explain what's wrong with each one. Anti-pattern 1. Text parsing for loop control. This is when your code checks Claude's output text for words like done or finished to decide if the task is complete. The problem: Claude uses natural language, which changes. Claude might say it's done with step 1 while still having 3 steps left. Stop_reason is always there, always accurate, never ambiguous. Use it. Anti-pattern 2. Fixed iteration cap as primary loop control. Using for I and range of 5 as the main mechanism. A cap of 5 cuts off a 6-step task at the worst possible moment. A safety counter is fine, and you should have one as a fallback. But the primary exit condition must always be stop_reason equals end_turn. Anti-pattern 3. Keyword detection for routing. Checking whether Claude's text contains certain words to decide which function to call next. This is fragile in 2 ways. Claude's wording varies, and Claude might mention a tool in context without actually requesting it. Read the structured tool_use blocks in the content array. They tell you exactly which tool Claude requested, with which inputs, reliably, every time. Let me close with the 7 things you must be able to recall and apply on the exam. 1. The loop pattern: send, check stop_reason, execute tools, append, repeat until end_turn. 2. Tools or descriptions. Name, description, schema. Claude never sees your implementation. 3. Stop_reason is the only control signal. Tool use means keep going. End_turn means stop. Never parse Claude's text. 4. The messages array grows every iteration. Claude sees the full history at each step. That's how it knows what it already did and what it still needs to do. 5. Model-driven means Claude decides what to do next. Your code is only the executor of Claude's decisions, not the planner of the workflow. 6. Tool results go back to Claude as user role messages, wrapped in a tool_result block, with the matching tool_use ID from Claude's request. 7. Use while true with a safety counter as a fallback. Never use a fixed range as the primary exit condition. That covers task 1.1 completely. You can now explain the full agentic loop, the communication stack, the 5 parameters, the tool description pattern, the 4-step cycle, and how to distinguish model-driven agency from scripted automation. In Part 3, we scale this up. Instead of one agent in a loop, we build multi-agent systems, a coordinator that spawns specialized subagents and synthesizes their results. You'll learn the hub-and-spoke architecture, the task tool for delegation, and how to design agent boundaries that keep systems maintainable. See you in the next video.